Hello. In the next 3 minutes or so, we'll be talking about hydrotreaters. The purpose of a hydrotreater is to remove sulfur to make a clean fuel. We're going to talk about where the hydrotreater is, what a hydrotreater does, how it does that, and how we at GE Water and Process Technologies can help. The hydrotreater is typically a separate unit. It is downstream of the crude unit and is used to treat individual stocks such as kerosene, diesel, resid, or naphtha. The purpose of a hydrotreater is to remove sulfur that's part of the hydrocarbon molecule. Nowadays, ULSD or ultra-low sulfur diesel requires 15 ppm or less of sulfur, and that is a very stringent specification. Gasoline allows a little bit higher, but it's headed down. Other purposes of a hydrotreater are to remove nitrogen and metals to protect downstream catalysts, typically a reformer catalyst, to saturate the olefins in a particular stock. The way this happens is a chemical reaction takes place at elevated temperatures over a fixed bed catalyst, typically in the presence of a large amount of excess circulating hydrogen, hence the name hydrotreater. Hydrotreaters use a variety of feedstocks, and each hydrotreater is typically dedicated to one or at most two feedstocks. These are the types of hydrotreaters that you may see in a refinery. A naphtha pretreater protects the downstream reforming catalyst by removing sulfur and nitrogen. Naphtha hydrotreaters treat FCC gasoline, which has too much sulfur for the current gasoline blending specifications, and that's going to be more stringent here shortly. Distillate hydrotreaters make home heating oil, kerosene, jet fuel, or off-road diesel. A special type of distillate hydrotreater is an ultra-low sulfur diesel hydrotreater, or ULSD. Here I state a maximum specification of 10 ppm. Most refiners will run to a 10 ppm sulfur specification in order to make a 15 ppm sulfur specification at the pump, allowing for back mixing with some more sulfur-laden materials. Another specialized type of hydrotreater is a hydrocracker, which is a two-stage process which, after hydrotreating gas oils, subjects them to even more severe conditions to crack them or make them into diesel and gasoline. Some hydrocrackers can take resid as a feedstock. This is the basic flow diagram of a hydrotreater. Charge, it comes either directly from the unit or from tankage, is preheated in a preheat train and then in a furnace, and passes downward over the catalyst in the reactor along with a large amount of hydrogen. That reactor effluent is then cooled in the same set of exchangers, goes to a flash drum where the treated oil and gases are separated, and then the H2S, which is a byproduct of the reaction, is separated before we have hydrotreated, sometimes called desulfurized product. This is the desulfurization reaction, where a sulfur molecule that is part of or a sulfur atom that is part of the hydrocarbon molecule is removed and is converted into H2S in the presence of hydrogen, catalyst, and heat. What we do to help a hydrotreater run: we can reduce fouling in the preheat train and in the furnace. Sometimes we do that with dispersants. Sometimes we do that with polymerization inhibitors. Often we use both. We can reduce the delta P in the packed bed reactor. We can disperse salt buildup that might happen in the effluent train, and we can model that salt buildup using our low salt model, and we can control downstream corrosion. Thank you.